Hey everybody, we are back continuing 8.4. Just so we're on the same page, I plan on finishing up 8.4 this week. You'll have this video and I think one more on Thursday, and then Wednesday and Friday will be reserved for practice problems. And then you'll have a quiz on Monday or Tuesday of next week on section 8.4. Before we get rolling today, just a quick review from yesterday's portion. Again, if you don't understand yesterday's, you can't really get today's. So we're just going to go over a few problems. Just switching between the two forms, that's very, very important for us. So remember, this is an exponential form, 5 squared equals 25, and 5 is my base there. That's the base of my exponent. So when I write this in logarithmic form, it's log base 5, because again, they have the same base. This is the base, so it's log base 5. And remember, it's left to the right power equals the middle. So whatever is set equal to on the right-hand side, in this case 25, that goes into the middle, and it equals the exponent, which is 2. So again, if I'm talking through this, left to the right power equals the middle. Okay, left to the right equals the middle. Okay, so now we're going to go backwards. Now we're going to have something in logarithmic form, and now we're going to put it into exponential. And again, it's left to the right power equals the middle. So left, 6 to the right, the number on the right is -1. 6 to the -1 power equals 1 over 6. And that makes sense, again, because negative exponents make us flip our number. Okay. So here we go. We do have a few special log cases. First of all, the log of 1. And again, this is written as log base b of 1 equals 0. So if I want to write that in exponential form, what would that be? Well, left b to the right power 0 equals the middle number 1. B to the 0 power equals 1. Well, any number we would plug in for b would be 1, because again, any number to the 0 power is 1. Okay, next up we have log base b of b equals 1. So if I write that in exponential form, that would be b to the first power, left to the right power equals the middle. Left to the right power equals the middle, which is b. B to the first power equals b. And that makes sense because any number we put in for b would equal itself. If I put in 6, 6 to the first power is 6. If I put in 52, 52 to the first power is 52. Those aren't really special cases. I know it's a special log values up here, but it's more so just common sense. You should know any number to the 0 power is 1, and any number to the first power is itself. That's all that this says. Okay, so now we're actually going to go into evaluating. If you don't have your perfects card out, you should have it out now. There are essentially 3 steps to evaluating these powers. First, set it equal to x. A lot of times they won't be set equal to anything. Actually, most of the time that will be the case. After we set it equal to x or m or z or any variable you want, I just pick x because it's easiest. We should rewrite it in exponential form, and then look at our perfects card. I'll show you what I mean by the first one. So number 1 says log base 5 of 125. And again, we got to put in equals x. Now, rewrite it in exponential form. Left to the right power equals the middle. Left number, 5, to the power of the number on the right, x, equals the middle number, 125. Well, now you just ask yourself, what power of 5 gives me 125? Well, if you look at your perfects card, 5 to the third power is 125, so x equals 3. Done. Okay, next up we have log base 32 of 2. And again, what I need to do is set this equal to x. I don't know why I was going to write 5 there. Equals x. So let's start by putting this in exponential form. So we have 32 to the x power equals 2. I'm struggling right now, sorry. Equals 2. So now, this doesn't really make sense because there's no powers of 32 on our card. But what if we thought about this in a different way? What if we said, well, how do you get from 2 to 32? Because we can't go from 32 to 2 on our perfects card. So what if we flipped it around and said, well, how do we go this way? Well, if you look on your perfects card, 2 to the 5th power is 32. So that means 32 to the what power is 2? Well, what we can do is just write it as a fraction. So we can write this as 32 to the 1/5 power. So all I did was I took this number and I flipped it. 32 to the 1/5 power equals 2. That means x equals 1/5. So one thing you guys should notice is that anytime you go from big number to smaller, so here we went from 32 to 2, that means your exponent will be less than 1 because we went from a bigger number to a smaller number. Think about it. If we have like 32 squared, well, that's going to get bigger. At what point would it start getting smaller? When my exponent is smaller than 1. Doesn't necessarily mean it's negative, but when it's smaller than 1. Okay, next up, number 3, log base 2 of 0.25. The first thing I'm going to do is I'm going to rewrite 0.25 as a decimal. That's one of 3 nice decimals. I call them nice decimals, 0.25, 0.5, and 0.75 because those are the easiest ones to just, boom, switch them in our head. So I'm going to write this as log base 2 of 0.25 is 1/4. And again, that equals x. So 2 to what power equals 1/4. Well, you should realize that 2 and 4 have a relationship. You should also realize that it starts as a whole number, starts as whole, and it goes to a fraction. So what that means is we're going to need to flip my exponent, so it means we're going to have a negative exponent. So now ignore the fraction. There's a 1 on top. So how do you go from 2 to 4? Well, 2 squared is 4. So that means x is going to equal 2, but again, it's going to be a negative exponent, so x is negative 2. If you have 2 to the negative 2 power, again, to flip that beast, it goes 1/2 squared, which is 1/4. On your quiz, a lot of people forgot that you can't have negative exponents as a part of your final answer. Here, it isn't really part of our final answer. It's just solving for what x is. Okay, last one. This one, we are starting with a fraction and going to a whole number. Let's rewrite it in exponential form first. 1/4 raised to the x power is 256. So similar to before, we are starting with a fraction and making it a whole number. So that means, again, we're going to need a negative exponent. So now, essentially, ignore my fraction. I know that it's going to have to be a negative. That's the only way to go from a fraction to a whole number, or vice versa, a whole number to a fraction. So exponent must be negative. I'm going to write that down. Because we go from a fraction this time, not a whole number. Because we go from a fraction to a whole number. So now ignore the fraction. Now just think, okay, 4 to what power gives me 256? You should say 4 to the 4th equals 256. What does that tell us? That tells us that x is going to equal negative 4 because, again, it's going to be negative. X is negative 4. Okay, last up, we have special types of logs. First of all, the common log. Now, it's called the common log. I honestly don't know why it's called the common log. But a common log has a base of 10, but the 10 isn't written. So in other words, if I have log base 10 of 75, we don't write the 10. It's just called log of 75. Okay? That's kind of what I wrote in the second line right here. It's written as log base 10 of 100, which is just log of 100. This is what the log button on your calculator means. Now, if you look on your phone, the phone's a little different, but if you use like a calculator that we have in school, if there's a button on it that says log, it's log base 10. It's not just log of anything, it's log base 10. If you open up Google right now and you type in log of 100, so, oh boy. Let's do this by hand before we do it on Google. So log of 100, if there's no base written, it's really log base 10 of 100. We'd set it equal to x. So 10 to the x power equals 100. 10 to what power is 100? You should say 10 squared is 100. So if you type log of 100 into Google, it'll spit out 2. Because again, the calculator, the base is 10. When there is on the calculator, the log button uses the base of 10. Now, kind of weird if you use an iPhone calculator. So if you open up your iPhone, I'm not sure about Android. First of all, it's 2020. Get an iPhone, losers. Just kidding. But if you do have an iPhone or an iPad calculator or whatever it is, if you turn it sideways to turn it into scientific, right to the left of the 4 button, it says log base 10. So it's like almost right smack dab middle of your screen if your phone is turned. So this is goofy. This one, just so we're all on the same page, people who can't see it, it says log base 10. So the iPhone lets you know, hey, this is the base. Most calculators don't do that. Most of them just say log. On an iPhone as well, it's goofy because you got to press the number in your calculator first. So if you want to find, I wonder if I can just get the calculator up right here. Oh, I don't have it. That sucks. Okay, never mind. Anyways, but if you want to figure out what the log of 100 is on an iPhone, you type in 100, then log base 10. 100 log base 10, 2 comes up. I don't know why it makes you do it different. Some calculators are weird. Okay, that's one special type of log. That's the common log. Again, a common log, it's the base of 10. It doesn't say that it's a base of 10, but it is the base of 10. The next one, this one's weird. This one is the natural log. So, oh boy, went too far. The natural log has a log base e. So, log base e is equal to a natural log. But we don't write it as log base e. We write log base e as ln of x. I remember it as log natural log, but it's backwards. Log natural of x. That's log base e. So this would be something I would make you chant. I would make everyone would hate me for this. I'd have everyone saying this 1,000 times in class. I would say log base e of x. And you'd say log base e of x is the same as ln of x. You need to know that ln of x is log base e, and it's called the natural log. Okay, moving on to some sorry, I got a little ahead of myself. I got excited. First of all, there's a button right in your calculator that says ln. Also, if you can use Google for this too. So if you type in the ln of 20, let's say the ln of 20, you get 2.999. That should tell us. So the ln of 20 is 2.99. Let's think about this logically. Now, if I wrote that in terms of logs, log base e is the same as ln of 20 equals 2.99. What does that tell us? That says left e to the right power, 2.99 equals 20. So e to about the third power, if you type in e to the third, you should get close to 20. E to the third, 20.08, okay? There's also an ln button on your iPhone calculator, so it's 2 buttons to the left of the 4. So again, you would have to type in 20, then hit the ln, and you get 2.99. Okay, we have 4 example problems. Now, this is all calculator based. So if you had a calculator, you just type in the buttons. I understand not everyone has an iPhone, but everyone does have a MacBook. You can go to Google and type these in if you want. So log of 85. If you're using an iPhone, type 85, then log. If you're on Google, type in log of 85 into the search bar. Either way, you get 1.929. If you want to pause this and try them on yourself, or try them for yourself, and then kind of check with what I do, that's fine too. Okay, number 2, if you type log of 1,133, again, this is really log base 10 of 1,134, not 33. So let's think about this logically. 1,134 is really close to 1,000, or pretty close to 1,000. And 10 to the third power is 1,000. So our answer should be somewhere around 3, because 10 to the third power is 1,000. So when we type this into our iPhone or our computer, we should get 3.055. Okay, next up, ln of 0.25. Again, just to kind of hammer this home, this is the same as log base e of 0.25. Again, e is a number. E is about 2.71. If we go from 2.71 to 0.25, that we're going down, so that means our exponent should be negative here. So if you type in ln of 0.25, you should get negative 1.386. Again, you're just plugging and chugging here. Next up, to hammer this home, ln is the same as log base e of 7.25. And again, e is 2.71. To go from 2.71 to 7.25, it's going up, so our exponent should be positive. Okay, if we type this in, ln of 7.25, we should get 1.981. Okay, that is all I have for you.